Hello everyone. I'm really glad to be here today, and I'm really proud to be talking about Scala 3 and Scala.js. I also want to thank the ScalaCon team for giving me this opportunity, and also a huge thanks to everyone being here today. My name is Adrien Piquerez, and I work at the Scala Center on open source tooling. In the last 2 days, we've learned a lot about Scala 3, the migration of the Scala 2 ecosystem to Scala 3, about the Scala.js support, and about all the tooling around the Scala ecosystem. So in this talk, in this presentation, I'd like to show you how all those things click together so that we can use Scala 3 today and build real application for the real world. So our mission will be to create a web application from scratch. And I will go step by step. I will use the existing Scala ecosystem. It's really amazing that we can use all the 10 years and more of Scala libraries to build new application in Scala 3. But also we will be able to benefit from the new Scala 3 features. I will try to use the principle of least power as much as possible. So I won't show anything that is smart just because it's smart, or anything that is fun just because it's fun. But I hope you will see some cool things in the presentation. Who is this mission for? So this mission is for web developers that are curious about Scala 3 and about the Scala ecosystem. It's also a mission for the JVM developers that want to learn more about Scala.js. It's really satisfying to see our Scala application being run on the browser. And it's really satisfying to improve and work on the UI and design of the application. It's also a presentation for Scala 2 developers that want to know how far they can get on building real application with Scala 3. What will you learn? You will learn to create a full stack build with SBT. A full stack build is a build in which you can compile the front end, in which you can also compile the backend, and in which you can package everything in a single jar. We will learn about cross-compilation to JVM and JS, and we will learn about the interop between Scala 2.13 and Scala 3. We will also see some of the new Scala 3 syntax and some of the new features. Okay, so one key to the success when you create a new project is to have a clear idea of what application you want to create. Here, for the purpose of this presentation, I want to create a little notepad so that I can create new notes and read the previous notes. So here, for instance, there is one note about the release of Scala 3 and another note about ScalaCon. And I'm currently creating a note about Scala.js in Scala 3. One important point is that I want all those nodes to be persisted on the server side, because I want to be able to access them at any time and with any device. As you can see, it's a fairly simple application, and hopefully we will be able to build it from scratch in these 45 minutes. The end result of the talk can already be found in this GitHub repository, and it's pinned on my profile. Okay, so a typical architecture of a full stack application. We have a web page that is composed of HTML files and CSS files. It's running on in the browser, so it must be powered by JavaScript. And then we have a web server. We can use different technologies to build a web server, but the JVM is perfectly appropriate. It's fast and it's reliable. The communication between the web page and web server is done with HTTP. So it seems fairly reasonable to use JS to write the front end and Java to write the backend. But when you are working with different language and working with different concepts, it's hard to switch from one language to another. So for instance, a JavaScript object is not the same as a Java object. And a Java function is not exactly the same as a JavaScript function. But also, those two languages have very different ecosystems. Those ecosystems are completely disjoint. So if you have your favorite testing library for JavaScript, you can't use it for the backend. And it goes also the other way. And finally, you will probably need to use the same data types on the front end and on the back end. So you will have a lot of duplication of code. What about using Scala 3? Indeed, Scala can compile to JavaScript with Scala.js, and it can also compile to Java bytecode and run on the JVM. So this solves two problems. You have a single language, which is mixing object-oriented programming and functional programming, and you have a shared ecosystem. Not all the Scala libraries are compiled to JavaScript, but many are, and I think more and more libraries will cross-compile. So for instance, you can use munit to test your front end and also to test your backend, or you can use Scala test, or you can use functional libraries like cats on both sides as well. So this is solving the two first drawbacks. But what about duplication of code? This can be solved easily by adding a third module, a core module that is cross-compiled to JS and JVM. It avoids duplication of code, but also it enables us to preserve the domain model and logic from the more technical code of the front end and the back end. So let's get started. Here is the SBT setup. We need SBT 1.5.1 to get Scala 3 support. And we also need the SBT Scala.js plugin to get the Scala.js support. Here I'm using SBT Scala.js version 1.5.1, but it's a pure coincidence that it's the same version as SBT. We will start by creating the web page. So this is my build.sbt. A little disclaimer first. So I'm currently using RC3 because Scala 3 final has been only out for 1 week, and there are one library that I want to use here and that is not yet available for Scala 3 final. So I'm sorry for that. In our web page project, I enable the Scala.js plugin. This will set up all the settings you need to compile to Scala.js. There is one little subtlety, which is the main module initializer. This means that our project is a standalone script. And this settings is needed for the linker to know that the entry point of the script is a main method. So basically, if you have a main method in your Scala.js project, you need to enable the main module initializer. If your project is a library, you don't need it. How can we manipulate HTML in JavaScript? We use the DOM interface. And in Scala.js, it's the same. We also use the DOM interface. And as you can see, the code is very similar. And that's because we use the same API and because the JavaScript syntax and the Scala.js syntax are very close. There is one huge difference, though, which is that Scala.js is a compiled language. So the compiler will check all your code. So here, for instance, I think I inserted a typo in text content. It should be a capital C. But how does the compiler knows about the type of the heading element? It needs to use a facade. So a facade is a piece of Scala code that only contains the signature of the values and functions of a JavaScript library. And hopefully, we already have one for the DOM, and it's called scalajs-dom. So it's available as a library, but it only contains the signatures of the JavaScript DOM. As of now, scalajs-dom is published for Scala 2.13, but we can use Scala 2.13 libraries in Scala 3. So the only thing we need to do is to tell SBT to fetch the 2.13 version of the library rather than the 3 version that doesn't exist yet. So that can be done with cross-version for 3 use 2.13. The DOM interface is a low-level API. So typically, we would use a web framework on top of it, like, for instance, React. Or in pure Scala.js, we can use Laminar. But I want to keep things very simple in this presentation, so I'm creating my own API. The first method is used to create a div element. So it takes a bunch of children and it adds them to a new div element. Then I have a method to create a heading, and the last method is for creating a button. As you can see, I'm using the optional braces syntax. So no, I don't use any braces right now. And I'm also using the for do notation, which is more elegant when there is no braces. I can now use this interface to build my web page. So the first thing is a little form that contains an input for the title, then a text area for the content of the note, and then a button. This form is added to a div, which is called the app container. It also contains the title of the application. Here, I'm defining the main method. I'm using the @main annotation in Scala 3 to declare the main method. And in it, I append the app container to the HTML body of the document. This web page can now be compiled, and we can create a single JS file. And if we add this JS file to an HTML file, we can open it in the browser and see the result. So I also did a bit of CSS so that the result looks better. But I won't be presenting this CSS. So if you are interested, you can check it in the GitHub repository. That's it for the web page. So we are now going to create the web server. Building web servers is very common in Scala and Scala 2. And there are a lot of Scala 2 libraries to build HTTP servers. For instance, there is akka-http, Play, HTTP4s, Finagle, and others. Here I have chosen akka-http. It's a well-known library. It has a nice DSL. It's also very well documented. Again, it's not published for Scala 3, but I can use the 2.13 version of it. And as you can see, and as you will see, it makes no difference. It's as if I'm using a Scala 3 library. So I want to define a base route that will return the index.html file. And in this HTML file, I want to access the different assets. So the CSS file, the JS file, but also maybe some images or other files. So the first route on the right, the base one, is using the / path. And there I get the index.html from the resource, the Java resource of my application. In the assets route, I say that the path starts with assets, and I take the remaining path, I put it in the file parameter, and I can get this asset from the resource. So this is really simple. For the index.html and for the main.css files, I can put them directly in the resource folder of my project. What about the main.js? It's compiled by SBT from the web page. So I will use SBT, and I will add a resource generator. So a resource generator, it is a task that SBT can run when compiling a project to create a resource file. So here, I'm using the scalajs linked file, which is a task that returns that compiles the web scalajs project, and that returns the path of the created file. And I copy that file to the resource manage folder. One good thing about this approach is that each time that the web server is compiled, the web page is also compiled, and the main.js file is added to the class path. So it's always in sync. And also we use the SBT incremental compilation. So if the scalajs file is already compiled, it won't be recompiled. And another good thing is that when I package the web server project, everything will be contained in a single jar. So this is easy to deploy, easy to publish. The main method of my web server. Here you can see that I'm using the given keyword in Scala 3 to declare implicit value. I don't need to give it a name, just because I probably won't use that name. So that's really nice. Then I create the HTTP server on localhost 8080, and I bind all the defined routes to it. That's it for the web server. We can now run it and test it on the browser. It doesn't seem like there is much difference than before, but now our web page is accessible with HTTP, so we can expose it to the outside world. We will now try to have the web page communicate with the web server. And for that, we need to create the node data class, and it needs to be compiled to Scala.js to be used by the web page, and also to Java bytecode to be used by the web server. So we create a cross project. For creating a cross project, we need a little SBT plugin called SBT Scala.js cross project. And then we can define a cross project on the JS and JVM platform. Here, cross type pure means that all the source file will be shared between the two platforms. There is no platform-specific source file for this project. For communication in HTTP, we need to format our data objects. And one very common format is a JSON format. So I want to use a JSON library in my little cross project. There are many libraries in the Scala, JSON libraries in the Scala ecosystem. Here I will be using circe for a simple reason, which is that circe is already compiled in Scala 3 and Scala.js. So I'm using two different artifacts. The first one, circe parser, is useful to parse a string to a JSON object. And then the circe generic artifact can derive some codec to transform our own data class to JSON and back to a data class. One thing about circe generic is that it is a macro library. And as you may know, we can't use Scala 2 macro libraries in Scala 3. That's why, in this case, I really need the artifact to be available in Scala 3. Okay, so, and the reason why I'm not using 3.0.0 final is that I don't have a circe generic on Scala.js for Scala 3 final. I can add these dependencies in my cross project as if it was it is a normal project. The only difference is that I need the 3% signs so that SBT fetch the platform dependent library artifact. I declare that the web page depends on core.js, which is the JS version of the core project. And the web server depends on the core.jvm. Here is the node case class. It only contains 3 fields: ID, title, and content. So here I'm using only one type of data structure. But if I want more different kind of data structure, I could use a Scala 3 enum. In the node companion object, I declare the JSON codec using circe generic. Again, I don't need to give it a name because it is now available implicitly, and it can be resolved automatically. In the same module, I define the interface between the front-end and back-end. So I want 2 different methods. The first one, getAllNodes, will be used to fetch all the nodes from the server. And the second one, createNode, will be sent by the client to the the server so that it creates a new node and it returns this new node. So it corresponds to the two routes, get API nodes and post API nodes. Okay. I'm now going to implement this service in the client with an HTTP service and in the backend to actually persist the nodes. So that's in the server side. I create the repository, which extends the node service. Here I'm using the file system to store the nodes as JSON file and to read them. But the implementation is not very different from what you can see in Scala 2. Again, I'm using akka-http to define the API route. So when I receive a get method on the API node route, I just call the getAllNodes method on the repository. And when I receive a post method, I expect the body of the request to contain a create node object. This create node object contains the title and the content of the node that we want to create. As you can see here, the JSON parsing is done automatically. That's because akka-http can consume implicit serializers. On the client side, I create the HTTP client, which also extends node service. This piece of code is much more interesting, I think, for today. So here we have an implicit parameter. Again, it has no name, and I don't need one. I won't use it explicitly. The implementation of the getAllNodes method. I'm using the fetch API that is contained in the DOM API and that is made accessible in scalajs-dom. The fetch API returns a JavaScript promise, but I can easily convert it to a future. To extract a JSON from the fetch response, I have defined an extension method. So it's a private extension method. It can only be used in the HTTP client class. And what it does is to look at the response. If it's OK, it extracts the JSON. And if it's not OK, it returns a failed future. Extension methods are very nice in Scala 3 to chain different operations. And they are very much more easily, you can define them very much more easily than implicit class in Scala 2. The last thing here is using circe to decode the JSON object to a sequence of nodes. This can fail, and if it fails, I throw the exception and it will be catched in the future. That's it for the getAllNodes. We can now look at the create node method. So here we define the fetch request, and there is this surprising pattern, I think, for many of us. So it looks like we are creating a dynamic object. So a dynamic object out of nowhere, and that we are defining some new fields in it. but that's not exactly true, as we will see. And I think with a bit of explanation, this pattern will feel more natural. So it looks like a dynamic object because the syntax is very close to the JavaScript syntax. But again, the difference is that if I make a typo in Scala, it will be catched by the compiler. So here, the compiler can tell me that there is no header without an S in this type. But which type exactly? So we can find the type in the Scala.js facade. It's defined in the class request. So the class request takes two arguments, the input and the init argument. The init argument is of type request init, which is a thread. And this thread contains a bunch of mutable fields. So now in Scala 3, you can create an anonymous class and the compiler can infer the thread of this class from the type that it expects. So here the compiler knows that it needs a request init. So it knows that the anonymous class that you are creating is extending this this thread. That's why you can't put whatever you want in the class. Maybe you think it's a bad pattern to use mutable fields, but I think here it's perfectly reasonable because it's a facade on top of a JavaScript library. The end of the method is very similar to the get all nodes method. And that's it for the HTTP client. So now we can use it in the web page. So when we start the web page, we can fetch all the nodes and we can add them to the app container. Also, when to create a new node, we can add a listener to the onClick event. So here, when the button is clicked, we get the value of the title input and the content text area, and we create the node, and then when we receive the response, we add it to the app container. And I think we're done. Our application is now ready to be tested. So I'm running it right now. And as you can see, I can probably create a new node. Yep, it's working. And then if I refresh, I have my new node here. Cool. So we're actually running a Scala 3 application with also Scala.js. And that is only 1 week after the release of Scala 3. So it's pretty cool. So that's it for the little example. So you can find all the entire result in the GitHub repository. And I hope this makes you want to create your own application, and that also this makes you want to learn more about Scala 3. So you can go to the Scaladoc website, and also you want maybe to discover more libraries, more Scala libraries. We have used akka-http, but there are a lot of other HTTP libraries. For instance, HTTP4S is built on top of CAT, and it's also very powerful. You can learn more about Scala.js in the Scala.js website. the Scala.js ecosystem is growing, and we have seen some very promising library. So for instance, this one, Laminar, it's a UI library. It's completely built with Scala.js, and it's very expressive and also very simple to use. So I encourage you to check it out. As we have seen today, it's rather easy to create an HTTP client and an HTTP server with Scala 3, but sometimes it can feel a bit repetitive. Hopefully, there are some very useful libraries. So, for instance, endpoint for us is a library in which you can define your endpoints and cross-compile them to Scala.js and JVM. And then they can be you can automatically instantiate the HTTP client and HTTP server. AutoWire is kind of the same library, but it uses macros. And another cool thing about Scala.js is that it's compatible with JavaScript libraries. And there is a lot of Scala.js library of JavaScript libraries available on the net, on the web. So for instance, you can find many of them in the NPM website. Here I was looking for a JavaScript library to generate HTML from Markdown. And that's it for the presentation. So I hope you enjoyed it and that you want to create your own application.
Hi, Adrien. Thanks so much for your talk. We do have a couple questions that I'd like to answer with you live, if that's okay.
Yes, of course, that's okay.
Great. So our first question is, what's the most exciting or helpful change in Scala 3, and how does it impact full stack development?
That's a very good question. So there are a lot of different of new features and different features in Scala 3. I know, for instance, that a lot of those features can help you with Scala.js. It makes Scala.js more, I think, more natural, maybe. So that's some exciting features, but we also have enum that are really easy to use and extremely, I think, simple. It can improve the readability of your code.
Great, thank you. The next question we have is, does the new syntax result in additional classes being created on the JS side, or is it optimized to a simple JS object?
A good question, and I'm afraid I can't answer it. We should ask to Sébastien, maybe, in the Scala.js Gitter. Maybe one thing I could say is that the new syntax doesn't change anything from what you would be doing in Scala 2. But in Scala 2, you need to write down explicitly the thread that you want to extend.
Right. Well, thank you. It does look like we have a couple additional questions. I'd love to ask you to head over to the Hopin stage Q&A area to answer those, if you don't mind.
Yes, of course.
Thanks so much.
Thank you.
Yeah, thank you very much.